Let me introduce myself first before starting on the next thing. The name given is Maisurah Syamimi binti Abdullah, and number student is 2025-208-508 from class N3AS0071A1. My purpose in making this video is to explain to you all about why does iron rust. Let's get started. Have you ever noticed that when iron is left outside, over time it turns reddish brown? That's rust, the main enemy of iron. But why does iron rust? Let's uncover the chemical secrets behind this phenomenon together. Actually, rust is formed through a chemical reaction between iron, oxygen, and water from the air. When iron is exposed to water and oxygen, the iron atoms begin to lose electrons and turn into iron ions. The iron ions will combine with oxygen and water to form hydrated iron oxide, or simply rust. The metal will turn reddish brown when the chemical reaction occurs. These are examples of rusted iron.
Miss, is there a way to prevent rust?
Of course, the way is that we can paint or plate the metal with zinc. Second, apply oil. And third, store the metal in a dry place.
Using a simple experiment. Place an iron nail in 4 test tubes. Fill one with regular till the nail is submerged. Fill another with regular tap water and add half a spoonful of regular table salt. Shake from side to side to ensure that sodium chloride fully dissolves. Fill with recently boiled water and add a thin layer of oil. When we boil the water, we remove oxygen, and the layer of oil prevents any oxygen from further dissolving. In the last, add a spoonful of calcium chloride. Calcium chloride removes moisture or water. Test tube, the nail is exposed to oxygen and moisture. In the second test tube, the nail is oxygen, moisture, and salt. So in the third test tube, the nail is only exposed to water. The nail is exposed only to oxygen. Stopper all 4 test tubes with a rubber bung a couple of days. You will find that the nails in the first and second test tubes have rusted. In part, the nail in the second test tube has rusted more than the nail in the first test tube, and the rust has off. You may see a reddish-brown precipitate at the bottom of these tubes. The nails in the third and fourth have not rusted. So what has happened here? The iron has undergone an oxidation reaction, iron trioxide or rust. Salt and acid act as a catalyst for this reaction. The nail in the second test tube formed more rust than the nail in the first test tube. Rusting if we have to constantly replace these items made of iron and steel. Rust can be prevented in areas exposed to oxygen and moisture. This is done on many bicycles and cars. Another rust is by placing a layer of oil or grease. This is done on many bicycle chains. It helps parts, which reduces friction and slows down the rusting process. Another way to prevent rusting is a method called galvanizing. Have a look at this reactivity table. Zinc is more reactive. When exposed to oxygen and moisture, zinc will corrode faster than iron. So if we put zinc protects iron but is sacrificing itself, hence the term sacrificial protection. To prevent rusting on ships. The oxidation of zinc can be described using this following. So besides preventing rusting, there is another advantage to this galvanizing process. The oxide layer can be removed, and the freshly exposed zinc can corrode once again, thereby further protecting.
For additional information, this process will happen faster if the area is humid, near the sea, or is constantly exposed to rain. So, do you all understand? If so, well then, we should not let rust eat iron. Therefore, we should protect it with chemistry. This is because, by understanding chemistry, we can take care of the world around us. That's all from me. Thank you for watching. Bye.